Hello, and welcome to Ethereal Mechanics Transvariance. Transvariance is the first paper of the Ethereal Mechanics series, and this is the sixth video of the Transvariance video series. In this video, we're going to talk about how to use the application software that was demonstrated in the first videos of this series. We're not going to show how to use the application, the executable, that you should already know. In this one, we're going to show you how to write simulations for the software, which will be made available to Patreon, Engineer, and above. That's the video series. This is the outline. So first, I'm going to give you a quick overview on how to find your way around, how to find the software, how to open the software, yada, yada, yada. Then we're going to begin with emission sources, and then barriers, and then triggers, and then trains, and I'll show you how to deal with length contraction. So to find the software, you go to the Patreon Ethereal Mechanics site, and you go down to the latest post area where you see the these are the tags of the 5 most popular tagged items here. Okay, if you see this little clear all box on, it means there's already been tags selected, and this tag search for Patreon is not very good. It's confusing. It doesn't seem like you can how to stack up tags, or if it is, I don't know how to use it. So the easiest thing to do is just hit the clear all to make sure that you don't have any tags already selected. Okay, once that goes away, you want to find the tag for software. Okay, software. They won't be in the first 5 here, so you have to click on this 218 more to bring up this, and then you click the tag for software. Okay, if you go scroll down, because there's no way to search through what you've already selected. If there is, I don't know how to do that. If somebody knows how to do that, let me know. And I found there's already a Transvariance simulation software executable, version 1.6 available. The source code and the new executable are going to be version 1. I haven't posted it yet, but that's what you're going to look for is version 1.8. And it's interesting here, the source code will be released beginning of 2019, and these will not be made public. I'm pretty sure I have not released those yet, which is interesting. But we're going to be releasing the new version now, so whatever. Okay, in the future, though, including this post, I'm going to be using for source code, I'm going to use the tag software source. And for the executables, which are going to go to first class and above, I'm going to use software executable so that the search won't give you everything. It'll just give you specifically those items. I'm still going to tag them with the old tag software so that you can still use the old method of finding everything. To use the Transvariance software, what you do is you go to your hard drive and you create a new directory or folder and call it code, whatever you want to call it. We're going to put your code. You go into there, and then you paste into there the transvariance.zip folder. Then you right-click on it and say WinZip extract to here. Okay, and they'll create the folder here. And here's the solution that you want to select. We're going to talk about that in a moment. Okay, so once you've unzipped the application, go to your Visual Studio, open it, and open project, and then navigate to the project. And then open the Transvariance Solution, SLN. Okay, it's going to come up blank. It may not come up blank for you because I'm going to probably leave stuff open when I finally actually do zip it up for you. So what you want to do first is you want to go to View and look for Solution Explorer. Okay, this will show you all of the files that make up the project or the solution, whatever you want to call it. Now, just for reference or whatever, we are not including any references other than the normal system libraries provided by Microsoft. So we don't have any hidden code in this, nothing hidden in a DLL. All the code that does all the simulation is all here. It's all available for you to inspect every piece of code that was written to do this simulation. Okay, so everything is available there. Now, to add your own simulation to this, first thing you want to do is open up the main form here. So double click on form 1, that's our main form. Okay, and then up here, if you want to, you can add your own menu and say your simulations. Okay, and then click away, and then click again, and then click in a box and say example 1 or source example. Yeah, just call it source. Okay, and then you click away, and then you double click on it, and that'll create a handler for that object. Okay, and then what you want to do is go back to your Solution Explorer, and you want to create, and you only need to create one. You want to add new item, and you want to add a class called your, and I'll leave this in so you don't have to add it again. I wish I could spell. All right, hit enter. Okay, so that's where we're going to put your simulations. All right, now what we want to do to make this, we just want to kind of make this public, and we want to make it static. Okay, because these are just going to be things that are going to create simulations that you're going to run. Okay, so we have an example simulation already here. And we're going to copy, this is under just the example simulation.cs. So you just want to copy this basic setup part right here all the way down to, and we'll add one object here. Okay, this example simulation, we're going to go over, it's going to give you everything you need for your simulation to get you started. So we go to your simulation, and we're just going to paste that in there. Okay, we also have to, now if you get all of this, it means you have to, include some libraries. Let me go back to the example simulation and just include these two items here. And that'll fix all how you put the Visine and get all the red out. It's supposed to. Transvariance. Oh, I know why. We need to call it something. Let's just do this too. Let's just take this. And that. Okay. Sorry about that. Just take the whole thing from the public static. So this is now a static function inside a static class. Keep this simple. This is a simple example. So what this is this is a function you're going to call. We're just giving it the name simple for now. You can call it whatever you want. It's going to return a universe object because the universe is what the simulation objects go into. And the input parameters are the train speed that you want, the camera speed that you want, the picture box that you want the simulation to go into, a trigger to stop the simulation, a reference to the trigger that will stop the simulation, the transvariances, and the simulation speed. Now you can add more parameters. You can see examples where we've added other parameters to other simulations as needed, but we don't need more for this simple simulation. So here is up to this point here, this is the basic simulation setup. So the first thing we do is create a reference frame for a train. The train is just the moving thing you put the moving objects on. All it is a reference frame that moves to the right at the velocity known as train speed, which is typically 0.3, which is 0.3 times the propagation speed of light, or whatever we're calling it. It's just the 1 unit. Its position is -7, 0. Now this position is relative to whatever you add this reference frame to. So in other words, the origin of this reference frame is going to be at -7 of the reference frame you add this to. In other words, we're going to add the train to the universe. Here's where we create the universe object. The universe, just for your information, okay, the universe is also a reference frame. Okay, it's just a slightly different reference frame that it has to keep track of time. That's it. Other than that, it's basically, and it also has to take care of all the drawing and the time for the universe. That's the only difference. Other than that, it's based on the basic reference frame object. Reference frame objects, you can put other objects into, including other reference frames. Okay, but so when we add the train to the universe, this -7 means that this reference frame will begin at universe reference frame -70. Okay, so the coordinates of your position are the relative to the reference frame that you add this to. And again, you can add reference frame to reference frame to reference frame. The next thing we're going to create is the ethereal reference frame. And again, if we go to this guy, we see this guy is also a derivative of reference frame. The only difference here is this is the place we paint the blue lines onto the screen. That's all this difference is. The only difference is for this ethereal reference frame is that it draws the grid lines. And if you want to change the number of grid lines, just change that number there. 31 seems to be fine for everything we do. Okay, so all of these are actually reference frames. So we have a reference frame for the train, for the moving objects in your simulation. We have a reference frame for the ether, which is going to be the reference frame that all of the photons or photon torpedoes are dumped out into. We're going to have a reference frame for the camera in case you want the camera to move. 9 times out of 10, camera speed comes in 0 because we don't want the camera to move. Okay, because the camera is how you view the universe. Okay, so then we create the universe. We're going to add the ether reference frame. We're going to add the train reference frame. We're going to add the camera reference frame, and then we're going to set the speed of the simulation time, which is typically, it defaults to tenths of units. If you go over here, the default is 1/10 of a time tick. If I say a tenth of a second, I mean a tenth of a time tick. Okay, last but not least, we're going to create the camera. And the camera is going to have a view of 30 units of width and 20 units in height. Okay, so if you want the camera to focus in closer, make those numbers smaller. If you want to see the simulations from farther away, make those numbers bigger. And we're going to basically, the PB1 is what we want the images of the camera to be painted on, which is a picture box, and this is a passed-in parameter. So literally, you can add more cameras if you want. Right now, the camera is only viewed from the top looking down, but you could have a different camera in a different paint box. And I haven't tried it, but it should work. I made it so it would be very general. And then we're going to add the camera to the camera reference frame so that the camera will move with the reference frame of the camera. If you don't want to bother with the reference frame of the camera, you can just add this camera to the universe reference frame. It won't matter. Okay, we'll talk about these in a moment. These are basically all the clocks, but we're going to keep those off for now. And then we're just going to add one luminous source to the universe. This is my Photon Torpedo launcher, I call them. Okay, the important thing now is when you set up these simulations, you have to pass in the Transvariances object. And that's okay. It's easy. I'll show you how you get those. And every object needs to know the Transvariances. I've thought about making an update where you just add the Transvariances to the universe and the universe will send it out to all the objects. But right now, I don't want to take the time to update that. So every object that needs luminous sources is going to have a field called var. Make sure you set those for everybody. Since this is a luminous object, you need to tell it which reference frame to dump its photon torpedoes into. And that, of course, is going to be the reference frame, of the ether. And then direction is the direction you want the photon torpedoes to go into, and that is relative to the reference frame that you dump this into. And we're going to do it in the positive x direction. And the position of the photon torpedo launcher is going to be at the origin of whatever reference frame we add this object to. The emission color of the photon torpedoes, we're picking green, pick whatever color you like. The number of photon torpedoes in the spread, and the spread angle in degrees. Right now we're just going to issue one pulse. And then trigger on start. That means once this thing is made, it's going to trigger the photon torpedoes. Okay, you can, in fact, have another source trigger sources of yada yada, and I'll show you an example of that. But right now we just want to start on beginning, and then we're going to add this to the train. Okay, now to start this, we go and we hit start. And we go to your simulations and we hit click source. And look, nothing happens. Okay, what I forgot to do here is I forgot to add a button handler for this. So we're going to stop this, go back to the form, double click on the source again. That's going to create the button handler. Now what I'm going to do is I'm going to copy the example button handler, and I'll show you what that does. Okay, the first thing we do is the simulation is the container that we put the universe into, which runs the simulation. First thing we want to do is set that to null to make sure any pre-existing simulation is stopped. And then we're going to call our your simulation, and it is simple. We're using the same name. Okay, and the first parameter is the train speed to the right, the camera speed. This is the paint box. We want to send this trigger. Here's our trigger stop. Okay, all this is the reference to a function. Go to definition. All it does is this thing is going to pass in the object that caused the trigger. All we're going to do is set its highlight to true to let the operator know which object triggered the trigger to stop. And then all we're going to do is shut off the timer, disable the timer 1. That stops the simulation. So that's all that does. That's a stop trigger. Okay, and here's the function to get the transvariance. This function will go out, interrogate all the buttons and switches on the form, and return to you a fully ferreted out transvariance object. And then, of course, is the sim speed, which I believe this is defaulting to 0.1. If you want to increase the resolution of simulation, make that number smaller. And right now it's just defaulted to 0.1. I don't have a setting for it other than there. 0.1 seems to do everything I need it to do, so I haven't bothered to make that settable. But if you want to go change it there. Okay. Okay, so now when we run, and then once we're done setting the simulation object from the creating thing, what you want to do is enable the simulation by setting the timer back to true. So that's all you need to do from the GUI standpoint, is just call the function that you made to create and return your universe object. And we can run that, and voila. Okay, there's our Photon Torpedo source, which is moving to the, because it's in the camera, it's in the train reference frame, it's moving to the right at the train speed, and it has launched a Photon Torpedo that's green to the right. Okay, so let's change this up a little bit here, and let's go back to our simulation. If you want to get there quick, you just right click and say go to definition. And let's make this, instead of making one Photon Torpedo, let's issue 11 Photon Torpedoes and make the span, 10 degrees. Okay, so now you can see you've got a wavefront that's expanding out. Now let's make it a little wider. Let's make it 30 degrees. There we go. Okay, so as you can see, if you don't have enough photon torpedoes, they're going to spread out and get thinner and thinner and thinner and thinner. So that's why I don't like the photon model, because it says at a long enough distance you could not detect stars because the distance between your photons would be too small that you wouldn't be able to catch them in a reflecting antenna or anything like that. So I don't know. but this for modeling these purposes, and modeling light as a photon is fine, even though I don't agree with the photon model for the purposes of simulation. Here it is fine. Okay, so now what we're going to do is we're going to add a barrier. And I'm going to use a barrier from someplace else because, you know, I've already figured out what all the parameters are. Control C, go back to your simulation, put in the barrier. I'm just going to call this B. If you highlight it, hit F2. We're just going to call this B for barrier. And we're going to add this to the train. That's fine. Okay, so the position of the barrier we're going to set at, now there's a reason for the WX and the WY. We're just going to, right now, I'm just going to set those values. Double WX equal 1. Double, it'll be clear what these are for in a minute. Okay, just set them to 1 right now. Okay, well, these are scalars because this is how we're going to do length contraction later. Length contraction is not automatic. You have to do the computations, and I'll show you how. It's pretty much done for you. Okay, so the position of the barrier, we're going to put at x equals 5. And we're going to set it at y location 0. And we're going to set the length of it is 0 in x and 5 in y. Okay, and then we're going to make the reflectivity 1, the transmissivity 0. So that's basically, if you want something to be, if you want a barrier to be a mirror, you set the reflectivity to 1 and the transmissivity to 0. If you want it to be an absorbing wall, you set both of these to 0. Let's make it an absorbing wall for now. And let's just run that and see what we get. Okay, so that's an absorbing wall. Okay, so the length, I wanted it to be centered. Okay, so the start position is going to be minus 2.5. That's not the center. That's okay. So the position is the start position, not the center position, and the length is from the position. I'd forgotten that. Apologies. Now let's make it again. Let's make it reflective. Okay, it's pretty straightforward. Now, let's try this now. We want it to stop the simulation when it detects. And so therefore, if we say B dot trigger out is equal to, and we're going to use the stop trigger, which is sent in up here. Stop right there. Stop. So we want it to stop. So it's going to issue a trigger whenever it detects that it's gotten hit by a photon torpedo. Okay, and that highlights the one that got hit. Okay, what else can we do? Now let's make it partial. Now, if you want to make it like a mirror, you know, like a reflective mirror that is a partially shaded mirror. Now, if you set these to a fraction of 1, okay, if you set these to 0.5, the luminosity of the photons will decrease. So this is how much luminous it reflects. So let's make it 0.1 so you can actually see it. So we're going to make it pass through and reflect, but only reflect 0.1 of the amplitude. Yeah, let's just do that. Oh, we got to stop. Turn off the trigger. F5. Oh, I made it too dark. You can see it. It's there. Let me make it not so dark. Let's make the photon color yellow. Easier to see. Okay, but typically I don't like to monkey with the reflections. I like to keep the reflections at 1. Okay, now if you want to make this a mirror that's pointing up, well, then you set the length to 45 degrees. So we want length to be, let's just make it 5 by 5. That'll make it a 45-degree mirror. Okay, so I think you get the idea. Now, if you want to add another source, another luminous source that gets triggered off of the trigger here, well, let's add another luminous source. Okay, we're going to put this luminous source at position plus, I don't know, plus 15, but looking backwards. And let's make its color cyan. Okay, and let's let's see, let's add it to the universe instead of the train. So it's not moving. We could add it to the ether. We could add it to all the other ones we want. Oh, I got to change this guy to S2. Okay. The easiest way to do this, watch this. If I just put a bracket here and a bracket here, okay, then I can double click that, and I hope this will work. Hit F2, and it'll just change those guys. Hopefully it didn't change these. No, it didn't. Good. Okay, so then I can just undo this. It's a little software engineering trick that a lot of people don't know. Okay, so what we want to do is we want to use the trigger. We don't want it to start to trigger when the simulation starts. So we're going to set this to false. And then what we want to do is say for barrier, we don't want to put that in here. We'll set this down here. So B, trigger out is going to equal S2 dot trigger. Now I should have called this fire or something else. So this is there's only one trigger input to a source, and that's it, just called trigger. Okay, let's see what happens now. Here's the other source over here. You just can't barely see it. See now, once these guys hit, that guy fires. So that's basically it. Everything, all the other simulations you see are pretty much done by photons, sources, and barriers. Now, the last thing we're going to show is how to deal with length contraction. All the other transvariances are handled. Length contraction was kind of that thing that allowed it optional. So what you need to do for length contraction is you are passed in an object called transvariances. Okay, so what you need to do right up here where you make your W's is you go tvars dot compute contractions, and then you want train speed. Okay, if you want to just put in the value for train speed, you can do that. Or if you wanted to go by the reference frame, you go train dot speed velocity dot magnitude okay, and then you type in out W1 or WX rather, and out WY. Okay, what that will do is it'll use whatever velocity you put in here. It's going to update these. In other words, it'll modify these based on that. And because you use these in your position and your length things for your barrier, you're going to see that these things are already modified. So that's what the W's and Y's are, so you can do the length contraction. Now, let's run this and set length contraction is on. Okay, you probably can't see it. So let's do this. Let's go back to your simulation and set the speed very, very close to the speed of propagation so that you can see the length contraction happening. See, now you can see that's a much tighter angle than it was before. Okay, and the last thing I want to show you within your simulation are the clocks. So if you enable this little block of code here, it'll add a clock to every reference frame. Okay, this should be pretty straightforward. You can change the color of the clock, the tag on the clock, whatever. And each one is added to an individual reference frame. We'll run that now. Well, let me turn the simulation speed back to normal. Set the simulation speed back to 0.3. And there's all the clocks. So that's a standard clock setup. We have a clock for every reference frame. So if your camera's moving, this little tag will move, you know, whatever. So the clocks will move with their reference frame. And they will time dilate according to the standard time dilation equation. Okay, so let's look at the other objects that are available to you. Okay, so all of the objects are available under reactive. And let's just go to the top and start from the top of this. Okay, so that's just the interface for the reactive object. So here's your photon. Okay, you don't have to deal with these directly. The sources will emit these. But if you want to put a photon out there by yourself, knock yourself out, you just create one and add it someplace and then give it a velocity, whatnot. Here's your barrier, which you should already know how to use. Everything that we have here is made out of barriers, whether you set them reflective or transmissive or whatever. Here's the pass-through color. If you want any object that passes through it, you want to change its color. Transparent means do not change the color. Keep the color as it was. So transparent is the no change color. Here's the reflect color. So if something reflects off it, you want to change the color just for the sake of identifying what objects have reflected. Okay, only trigger on specific color photon. Okay, so what might happen is if you have a whole bunch of photons coming at you, you only want a specific color, and this would be the trigger color. Okay, so that's if you want only a specific. So when you emit a source of photons and you set their color, you can tell that for this barrier to trigger only when a specific colored photon hits you. Okay, that's another thing that I didn't show you because it's not part of the thing we do normally here, but it's there. Okay, and this is just the trigger class. Okay, here you can clone them if you want to make more than one, the normal items. Okay, here's your burst trigger. I haven't shown this yet, but a burst trigger is a way that you can, there's an example in there for the waveguides where we burst multiple wave fronts coming out at once. That will give you an example how to use the burst trigger. Here's your luminous source. We've already shown you how to use those. You have to set the reference frame of light. Here's your emission color, a special direction color, and you can mark every nth emission to have a different color. I believe that's what this is about. The rest you should already know. So now we're going to go down to the next object, which is the field source. Okay, this was used in the emission and one of the examples. It's only, I think it's only used once. It says it's referenced 7 times, but there is it's only used, well, it's used a number of times. So if you want to see how it's used, you can go over, you click one of these. So the way you find out, you should click on references, and then you can click over here to see how it's being used somewhere else. Okay. And then we have the clock. I just showed you how to use those. Oh, and here's a counter. A counter is an object. There's examples here on how to use the counter. What it is, all the counter is, every time this gets a trigger, it'll increment the count, and it'll put the count on the screen for you to see. Okay, so that's all that is. That's a very handy thing if you want to use it. There's not really much than that there. The only other set of objects are, here's your reference frame, here's your trigger, waveguide. So we have waveguides. Okay, the waveguides are very complicated. I'm not going to get into the video of how to use these now. Ultimately, though, if you want to go use look at the examples where the waveguides are used, it's basically a cell. And whatever start direction you start, if you hit add your next waveguide onto C, then that waveguide is going to start building to the right, and the new waveguide is going to have its B to the right. Okay, so if you want a waveguide that goes around in a square, you just keep adding to the C side and the C side and the C side, and it'll come around. And so you have a cell, and so what you need to do is set the initial block size. And then if you want a straight waveguide going up, you just keep adding to side B. Or if you want it to start at the right, you hit side C and then just keep adding to B, and it'll just grow off to the right. Okay, so there's a little bit of documentation here. The corners are lowercase and the B, A, uppercase are the sides. So I'm not going to get into how to use these. I'm not crazy about their performance. The nice thing about these, though, is they automatically do the length contraction. Okay, so that they already take care of the length contraction. So, and what you do is when you look in the examples, you build your waveguide into a waveguide collection, and then you add the waveguide collection to the universe. So, if anybody really can't figure these out and they want to use them, then I'll do a separate video on the waveguides later. That's pretty much all that's in here. All the simulations are built from the basic parts that you saw, whether they be reference frames or, you know, or emissive sources or whatever. Okay, I hope you enjoy all of this. This looks like it could be a lot of fun. I'd like to see what people come up with. What kind of, you know, simulations where you get stuff bouncing all over the place. things changing color. And because you have full access to the source code, you can make whatever new objects you want to do whatever you want to do. Everything here is pretty much basic and simple. It's just basic object-oriented programming. Anyway, thank you.